Hi, this is the video for growing number 4. We're about halfway through our growing linear versus exponential unit. Here's the objective for the day. I can find growth rate and growth factor and use them to write exponential equations. So on your classwork, we're talking about Sam. When he was in 7th grade, he got what every 7th grade boy wants for a birthday gift. He got a stamp collection. Woo! But then his aunt told him it was worth $2,500, and so of course the first thought he has is, I want to sell it. But then his aunt told him that if he saved it and did not sell it, it would increase in value. And so Sam did save the collection, and the value increased by 6% every year. So let's figure out how much it's worth. I actually am going to change my table right here. Instead of 1, 2, 3, and 4, I'm going to have that start with a 0. Because in the beginning, his stamp collection was worth $2,500. Then 1 year later, how much is it worth? Well, the stamp collection was worth 100% of what it used to be, plus 6% more. And so that means that after 1 year, this stamp collection is 106% of what it was before. And so how do you find 106% of something? Well, first you have to turn your 106% into a decimal by dividing by 0. 106% equals 1.06. And now if you multiply your 2,500 times 1.06, you will get $2,650. That's the value. Some of you might be thinking, why is she doing that? Why doesn't she just take 2,500, multiply it by 0.06? That'll tell you how much it's increased by, which is $150, and then you can add it to the $2,500, and that'll give you $2,650. Why don't you just do that? Well, you can, but my way is actually faster. This way you had to do 2 different steps. First you had to multiply, then you had to add them together. And when you do it my way, you actually add those percents together first, and you can do that in your head. 100% plus 6% is 106%. Sweet. And I can turn that into a decimal just by dividing by 100. So I got the 1.06, and that is what I'm multiplying by every time. Okay, so that should sound kind of familiar. If I say I'm multiplying by 1.06 every time, does that make you think about something? Something like a geometric sequence, maybe? Well, 2,650 times 1.06 is 2,809. You're going to multiply by 1.06 again, and you are going to get 2977.54. And you could keep doing that to fill in the rest of your table. The point is, when you're multiplying every time, we're not really dealing with geometric sequences anymore. We are dealing with exponential functions. And when it grows by multiplication every time like that, then it is, yes, that is an exponential function. So for number 2, the answer is yes. Now let's write an equation for this. Let's write an explicit equation for the value after so many years. It suggests that we use value for v, so I'm going to do that. And what is our initial amount? What did we start with? That stamp collection was worth $2,500 at the very beginning, before we started. And then every year I am multiplying by 1.06, and I'm going to raise that to an exponent of x. Why did I use x and not x minus 1? Because so far a lot of our equations have said x minus 1. Well, if you will remember, we wrote a bunch of different explicit equations, and so if I wanted to use the 1 up there, I would have to say 2650 at the very beginning. So as it is right now, it's kind of like I'm saying x minus 0, that the 0 term is 2,500. So remember, that's like using this term, x minus 0. I could have said 2,809 and then x minus 2 as my exponent. There's lots of different explicit equations you can write. I think it's a good idea to start using the zero term every time because that makes it just a little bit easier to plug in numbers. Okay, let's talk about, where are we? Okay, one more thing. This thing that you multiply by every time, this thing that is in the parentheses, this thing right here, this number, we used to call that the constant ratio. Well, now we are going to call it the growth factor. Sorry, my stylus is squeaky. That's weird. It's the growth factor. The growth factor is the thing you multiply by every time. So for a good idea would be to write this on your notes or on your classwork actually in big huge letters. The growth rate is a percent. Put that somewhere on your paper so you can remember when it says rate, you need to have a percent on it. So then, just as a little review, the growth factor is the pattern. That is this 1.06. That's the growth factor. It's the pattern. That's the growth factor, which is different than the growth rate. So we like to talk about the growth rate as being like a percent of change. What percent did this increase by? So it increased, well, it was still worth 100% of last year's value, plus some more. So what is the some more as a percentage? That's growth rate. How do you find the growth rate? Well, this is a good idea to copy these down into your composition notebooks maybe or on your classwork. So if you need to pause the video and copy this down right now, that's a good idea. To find the growth rate when you've been given the growth factor, first multiply the growth factor by 100 to turn it into a percent. And then you're going to subtract 100% to find out what that increase is. And since you're finding the growth rate, your answer should be a percent. So let's look at the first example. The growth factor is 1.06. In fact, that is the same growth factor that we were just looking at right there in that equation. If the growth factor is 1.06 and I multiply that by 100, I will have 106%. And then I'm going to subtract 100%. Well, 106% minus 100% is 6%. And so the growth rate is 6% if the growth factor is 1.06. Okay, let's do another one. This time you've been given the growth factor of 1.59. So if you multiply that by 100, you get 159. And then you need to subtract 100%. And so it is 59%. How about this next one? First multiply by 100 to turn it into a percent. Multiplying 2.8 times 100 means you get 280%. Now we're going to subtract off 100% to find out what the increase is. So that's just going to be 180%. For the growth factor for 57, it's just plain 57. If you turn that into a percent, that is 5,700%. And then you subtract 100, so that means that our growth rate is going to be 5,700% minus 100% equals 5,600%. That's a lot of growth. Okay, what about going the other direction? If you have been given the growth rate and you need to find the growth factor, why would you need to find the growth factor, you're wondering? Well, the growth factor is what you use to actually write the equation. The growth rate is useful information, but you want to write an explicit equation, then you have to use the growth factor. So to change the growth rate into growth factor, you need to add 100% to the growth rate, and then you're going to divide by 100 so that you can represent it as a decimal. And your answer should not be a percent. You're converting your percent into a decimal growth factor. So we should not see a percent sign at the end of any growth factors. Remember, the growth factor is the pattern or the ratio. It's the thing that went inside the parentheses as the base for your exponent. And then you had your start over here, your first term or whatever. So growth factor is the pattern, the thing that you multiply by every time. Hey, let's do some more examples. What if the growth rate is 4%? Well, you're going to add 100%, so you get 104%, and then divide by 100 to turn it into a decimal. That's 1.04. Okay, how about 75%? Well, that's 175% because it's worth all that it was last year plus 75% more. So it's 175% of the original price. And what would we multiply by if it was 175%? It would be 1.75. Okay, so this next one, add 100% and you're going to get 103.25%. And then you're going to convert, well, percent, and that becomes, as a decimal, 1.0325. Okay, last one. You still have to add 100%, even if it's a whole number, even if it's bigger than 100. So adding 100% to that would be 318%. And then converting it into a decimal would be 3.18. All right, let's look at some stuff on your classwork. Some specific problems. So the growth factor on number 5 is going to be 1.04 because now we're looking at a stamp collection with a different rate of increase. It's only 4% this time, and so the growth factor would be 1.04 and the growth rate would be 4%, right there, 4%. Okay, if you had to write an equation for number 7 that represents the value of the stamp collection, you would say that the value for any year is 2,500 times 1.04 to whatever year you're trying to find. So that's one way to write an equation. You could have said f of x. You could have even just said y equals, I don't care. Okay, on the back, I want you to pause this video for just a couple of minutes and try to do numbers 8 through 11 on your own. And when you come back, I will read off some of the answers, not all of them, but I want you to actually try them on your own and see if you can do this. So, number 8, ready, go. Okay, welcome back. I'm going to do 8, D, E, and F. So for number 8D, you were given 75%. That's the growth rate. That means that it was worth 100% of what it used to be plus 75% more. The growth is 175% of what it was. But I don't ever have a percent sign in an equation, and so I'm going to convert that to be a decimal by dividing by 100, and so it's 1.75. Following that same procedure for E, you're going to add 100% to that. That makes it 200%. And then you're going to convert your percent to a decimal, and so your answer is just plain old 2. Last one, 150% plus 100% is 250%. Convert that into a decimal, and you get 2.5. Okay, so the number 9, how can you find the growth factor if you know the growth rate? It's what I said in the notes a little bit before, so you can look back and figure that out. And then number 10, let's just talk about the last row again. D, you're going to first multiply by 100 to turn it into a percent. So 2.3 is 230%. Then you need to subtract 100% off, and so it's going to be 130%. So it's kind of like working backwards from what we did on 8, A through F, because this time we are multiplying by 100 and then subtracting 100%. So you can see from the steps up here that that's actually working backwards. Now be very careful on E and F because many mistakes have been made and points have been lost by people confusing these two. So 1.8 is 180%, and when I subtract off the 100%, I am just left with 80%, 80. When I do the same thing with F, I am left with 8%. Those are different. Make sure you know the difference. Okay, number 12 on the classwork it starts off with just a regular old explicit equation, and we have 1.09 to the x power. So now it says, what's the growth factor? All you have to do here is remember and recognize, oh yeah, the growth factor is the thing that lives inside the parentheses there. It's the base of the exponent. It's what you multiply by every time. So for 12a, the growth factor is just 1.09. And the growth rate, you need to convert that factor into a rate by multiplying by 100 to get 109%, then subtract off the 100% to just find out what the increase was, and it's 9%. And then for C, evaluate the equation if x equals 5. You are taking the equation that they gave you, and instead of x, you're going to put in a 5. And when you type that in the calculator, be careful. 3872, and then you can hit the times 1.09. Do not hit enter. If you multiply those two things together first, you will get it wrong. Your calculator will know what to do if you enter it like that with the caret sign to raise just the 1.09 to the 5th power. And the answer is like $5,957.55 or something like that. It's not even dollars and cents. Okay, 13. Growth rate is 2%. That's what they give you. B, growth factor must be 1.02. And I'm going to let you work on the explicit equation and finding the value. Last thing we're going to do is just talk about this, the homework. So this is homework. We're talking about wolves. Now, you need to use some common sense for the rest of this chapter, because if we are talking about some kind of population of a mammal or a human or something like that, you need to use common sense. It doesn't make any sense at all to talk about maybe like 2.4 wolves. What would that look like? I don't want to see 0.4. I don't want to see 4/10 of a wolf. That would be disgusting. So you want to make sure that you are using common sense and rounding when appropriate. If it's money, you can round to the nearest hundredth. If it's a human, you better round off to the nearest human being. And so we'll just say that if it's 5 and up, you round up. If it's less than 5, you round down. Okay, so for our table for this wolf population, hey, let's draw, not erase. In the beginning, when we started, there were 20 wolves. And then it says in the problem that the growth factor is 1.2. So that means I'm going to be multiplying by 1.2 every time. Now 20 times 1.2 is 24. So after 1 year, there were 24 wolves in Michigan. And now to find the next one, you're going to type 24 times 1.2 again. But this time it's not a whole number. You're going to multiply by 1.2 and you get 28.8. Don't write that down in my table because 28.8 wolves is gross and disgusting. We can round that off to 29 wolves after 2 years, but don't change your calculator. Just leave the 28.8 in your calculator, and then for the one after 3 years, you're just going to say 28.8 times 1.2 again. Oh, yeah, that says times, and that says 1.2. So 28.8 times 1.2 gives me 34.56, and I'm going to go ahead and round that up to 35 wolves. So it's like you leave it in your calculator unrounded. Don't retype it in as 29 times 1.2. No, just leave the decimal form in your calculator and round off as you write down on the table so that we can be talking about whole numbered animals. Okay, I think you can work through a lot of that. I think also that I want to talk about on the back, maybe number 7. Here's number 7. A $5,000 violin increases in value by 20% each year. What's the growth rate? Whenever you're given the percent like that, that's probably the growth rate. It's 20% and it's increasing, that's the growth rate. How do you convert that to be a growth factor? Well, you need to add 100% to the 20%, so it's 120%, and then convert that to be a decimal, which is just 1.2 or 1.20. Okay, so I think that gives you enough information to finish your homework. You can email me with any questions, and good luck.